Welcome to the Explainer. Today we're diving headfirst into a really fascinating journey to unmask the hidden technology that literally runs our modern lives. It's something we interact with dozens, maybe hundreds of times a day, usually without ever realizing that it's silently calculating and making decisions right there on our behalf.
So I want you to take a quick second and just consider this. What is the hidden power that seamlessly connects your kitchen appliances, the car you drive, and the sprawling global transport grid? Like, what's that common thread, taking a completely ordinary piece of metal and plastic and suddenly giving it the ability to, well, think?
The answer? Microprocessors. These are the tiny, totally invisible brains that are actively rewiring our homes, our transport networks, and honestly, our entire society. They are the absolute bedrock of the modern world, just sitting silently inside buildings, beneath the roads we drive on, and right there in the devices in your pocket.
Okay, Section 1. Meet the invisible brain.
To really understand this invisible force, let's break it down to the basics. Fundamentally, a microprocessor is just a tiny computer chip. You can think of it as a brain implanted into a machine. It takes machines that are traditionally dumb, meaning they only do exactly what a human physically forces them to do, and it instantly makes them smart by processing data and controlling exactly how they work.
It's actually a lot like human biology. For a machine to be smart, it needs a body to interact with the world, right? So sensors act as the machine's eyes and ears, gathering data from the environment. Then the microprocessor chip acts as the processing brain, taking in all that sensory information and deciding what to do. And finally, the actuators serve as the muscles, physically executing the actions, like turning a motor or flipping a switch.
Moving on to Section 2. Microprocessors in our homes.
When we scale things up to our highly networked living spaces, the microprocessor is no longer just working alone. It's part of a massive team. We now have smart fridges with chips that actually track your fresh food inventory and automatically reorder groceries for you. Out in the kitchen, automated ovens don't even have dials anymore. You literally just scan a QR code on the food packaging, and the oven instantly sets the exact timer and temperature. It's entirely automated domestic living. Now, if we look closely, all these daily domestic devices fall pretty neatly into two distinct camps. First up, we have labor-saving devices. These are engineered to actually do physical work and automate our chores. Think of your robotic vacuum or your washing machine. Then we have convenience and entertainment devices. These aren't really doing physical labor. They're designed to manage our information, our media, and our free time. So that's your smart TV or an automated alarm clock. But here's the catch. Delegating all this physical labor to machines introduces a major trade-off. Sure, we gain incredible benefits, like unprecedented free time and high-level automated security for total peace of mind. But on the flip side, we face some really serious personal impacts. Relying heavily on automation means we risk developing sedentary, lazy habits. And even more critically, we risk losing basic household survival skills. I mean, when the oven cooks and the fridge does the shopping, we kind of start to forget how to actually perform these fundamental life tasks ourselves.
Section 3. Automating global transport.
When we scale this technology all the way up to autonomous or driverless cars, our whole biological metaphor gets put to the ultimate test. The vehicle operates on a continuous, never-ending loop of sensing, thinking, and acting. It literally sees using radar and ultrasonics as its ears, while cameras act as its eyes to read road signs. The microprocessor is the brain, analyzing this immense wave of sensory data in mere milliseconds. It calculates way faster than a human ever could, which effectively removes human pilot error and then commands the actuators to physically steer the wheel or slam on the brakes.
And this automation doesn't just happen inside the car, it's happening on the roads themselves. Imagine a crash on a smart motorway. Step 1. Highway sensors instantly detect the incident. Step 2. In real time, central microprocessors analyze all the surrounding traffic data. Step 3. The system automatically reacts, instantly altering speed limits on digital signs and closing specific lanes miles ahead of the crash. It's a completely immediate automated response designed to keep traffic flowing and prevent massive pileups.
Implementing this global-scale automation brings massive, undeniable gains. We're talking drastically reduced traffic congestion, perfectly punctual train networks, and the total removal of pilot-induced errors in planes. However, we simultaneously face some pretty severe shared risks. Across all these vehicles, the fear of malicious hacking is very real. Furthermore, something as simple as heavy snow can cause sensors to fail, and software glitches in a pilotless airplane present a profound systemic security risk for everyone on board.
Which brings us to Section 4. The hidden human costs.
So pursuing a totally automated, frictionless life actually creates a massive amount of environmental friction. On one hand, microprocessors offer incredible energy efficiency. Devices automatically shut down to save huge amounts of household electricity, but that gain is completely offset by our modern throwaway culture. Smart boards are incredibly complex and notoriously difficult to fix. Today, it is usually way cheaper to just throw away a broken smart device than it is to repair it, and that is actively driving a severe global e-waste crisis.
We also face a deep social and security friction. Yes, unseen networks allow us to make free video calls globally, completely breaking down geographic barriers. But reduced face-to-face time can easily lead to social isolation and cyberbullying. And from a security standpoint, because everything is networked, any internet-connected device is basically an open window. Hackers could theoretically track when you're on holiday or, crazy as it sounds, even steal your credit card details straight through a vulnerability in your smart fridge.
Section 5. The Ultimate Smart Paradox.
This brings us to the core tension of our modern world. It's the smart paradox. On one side, we are driving aggressively toward total frictionless living, using microprocessors to successfully eliminate physical effort and dangerous human error. But as we achieve that frictionless living, we expand into total vulnerability. By entirely relying on complex networks to run our lives, we introduce deep, systemic vulnerabilities, ranging from global e-waste to degraded survival skills and, of course, ever-present cybersecurity threats.
So what are the big takeaways today? First, microprocessors are undeniably revolutionary. They make our lives incredibly easier at home and significantly safer out on our transport networks. Second, enjoying this technology requires that we actively guard against the human costs, like physical laziness and the loss of independent life skills. And third, the global e-waste crisis and the constant threat of hacking are the defining challenges of our time. Living in a smart world requires active, conscious engagement. We just can't put society on autopilot.
I want to leave you with a final, somewhat provocative thought to consider today. As we continue to engineer a perfectly frictionless world, handing over our chores, our transport, and our decisions to invisible brains, are we simply automating our own vulnerability? Thank you so much for joining me for this explainer, and I highly encourage you to keep questioning the technology that surrounds you every single day.